Hello, Professor. What are you doing with all those petri dishes? Hi, Professor. I'm investigating the amount of bacteria found on washed and unwashed hands. Wow, that seems really interesting. How do you do it? Well, I put my handprint from an unwashed hand onto the plates. I also put my handprint from washed hands onto the plates. The nutrient agar in the petri dishes is perfect for growing bacteria. I'll put them in the warm incubator for 3 days and then I'll measure how much bacteria has grown. Wow, that sounds great. But why do you need so many plates? Because cows moo softly. Huh? Cows moo softly. Still, huh? Let me explain. It's a mnemonic. What we need to do is change something, measure something, and keep everything else the same. I need to use my precious time and resources well and make sure that I conduct a fair test. If I don't do that, we won't know what's caused any changes and we will learn nothing. So you see, to make it a fair test, scientists need to change something. That's the independent variable. In this case, that's washed or unwashed hands. Secondly, we need to measure something. That's the dependent variable. In this case, that's the amount of bacteria that's grown on the plates. And then thirdly, we need to keep everything else the same. In this case, that's the amount of nutrient in the plate, the way the plates were prepared, the time and the temperature that the plates have in the incubator, all the things like that. That way we know that any changes to the bacteria coverage are from the hand washing and not from anything else. But what about all those extra plates? Why so many? Some plates I'm doubling up on to add on reliability. The more often something occurs, the better. These ones over here are the controls. These plates hopefully won't grow any bacteria. If they do, then that says that the plates were contaminated and the nutrient agar wasn't sterile to begin with. And that means that the whole experiment is invalid because we won't know if the bacteria grew from something on our hands or if it was already in the plates to start with. That's why they're called the controls. Gee, that's interesting. What's interesting? Oh, hi Mac. The professor was just explaining to me about conducting fair tests and controlling variables. Oh wow, that's just what I've been doing too. I've been investigating the effects of exercise time on heart rate. The thing we've changed, the independent variable, is the length of time. All the participants have exercised for different amounts of time. We've been measuring changes in heart rate. That's our dependent variable. We've kept everything else the same. Age, fitness, hydration, etc. have all been controlled for. Wow, that is interesting. It's not always as simple as that, though. As a paleontologist, I study fossils. I don't have a time machine to go back millions of years ago and get dinosaurs to die in controlled conditions so that I can measure the independent variable. I can, however, make observations and compare what I can. As a zoologist who works in the field, I find similar issues. I also see it in things like dissections. When I do a dissection, I'm not conducting an experiment with variables. I'm making observations and using them to further my own knowledge. Medical experiments are complex too. We do have some ways of testing and experimenting with new medicines and procedures, such as animal testing, cellular testing, and then clinical trials, such as double-blind trials, where one group of people are given medication and the other group are given pretend lolly tablets. but this isn't always possible, and the ethics are very complicated. Gee, I've learned so much today. To be a fair test, experiments need to change something, which is the independent variable, measure something, that's the dependent variable, and keep everything else the same, that's the controls. It seems this isn't always possible due to logistics and ethic, but it provides a framework that enables us to learn from observations. Wow, it seems cows really do moo softly.